Hello everyone and welcome back to this series of pulse measurements using Anritsu vector star with option 35 and 42, which helps you to resolute pulses as low as 2.5 nanoseconds and also gives you a freedom of record length of 500 milliseconds. In our last video we actually saw how we can do a pulse profiling using our pulse demonstration module. Although I also have the pulse modulator test set included in my measurement, but right now, as I explained in my last video, I was using pulse generator 4 from the vector star and feeding it to our pulse demonstration module. Now I will show you the advantages of having independent receivers, the ability to configure independent receivers when it comes to vector star. So in this video I will revive of what I did in the last video, and then I will now use our pulse modulator test set instead of the pulse demonstration module that I was using in the previous video to pulse the RF coming from the VNA. So as you can see, our setup in last video for pulse profiling was that I was using PG4. I had enabled the pulse generator, as you can see, PG4. I was doing the singlet and the polarity is inverted because that is where the switch get closed in our pulse demonstration module. The pulse width is 200 nanoseconds. Again, the measurement that I'm doing is a pulse profile, and right now my receivers are coupled. That means all the receivers that I have are basically coupled here, and the measurement bits was 2.5 nanoseconds start, 0 stop, 400 nanoseconds, and the number of data points for non-overlapping measurement windows is 161. So when I do a done, I should be able to see my pulse, which we have been analyzing in almost all our demonstrations. But now actually I have connected my pulse generator, internal pulse generator 1 to the Anritsu pulse modulator test set, which again comes into various configurations. We have 4 models available, 2 of them going up to 40 gigahertz, and the reason that we have 2 versions in the 40 gigahertz is the fact that one can only do source modulation, but the other variant can do both source and receive modulations as well. Similarly, we have 2 models for 70 gigahertz. Again, we are the only ones in the market which have a pulse modulator test set going up to 70 gigahertz for any pulse capabilities. Again, both the versions in the 70 gigahertz model also cover, one of them covers only the source side for the source modulation, and the other one has both source and receive modulation as well. So moving on, right now I've connected PG1 to the pulse modulator test set, and so now I am not using my pulse demonstration module. And the fact that I wanted to show you and club this demonstration with Anritsu's SM6628 or other pulse modulator test set is the fact that sometimes what happens is that your DUTs, the DUTs which are made to operate in pulse conditions, they have some delay associated with them, and the fact that it might be a very long cable or the DUT itself is very long, so that adds in some delay from the transmit side, then it goes to the DUT, and then it gets received on the B2. So when there is a delay, then the when there is a delay between the transmit side or the reference receiver, say A1, and because the receiver side on the receiving side of the DUT is B2, if there is a time delay between the two, then the S parameter will have some issues, and that is why the ability to have independent receivers is very useful. This will get more clear when I show you in the demonstration. So again, this time instead of PG4, which I was using for all the demos, I'm going to switch off PG4 because we are not using that. Right now I'm going to use PG1. I will enable the pulse generator. I will again do a singlet and again an inverted polarity, and this time the width again is 200 nanoseconds only. So I'm not changing anything. It's just that you are going to see the the pulse, instead of PG4 which was green, now you will have PG1 which is blue in place. Rest of the things, everything is fine. And now because you know there are a lot of components inside the pulse modulator test set, and still the DUT, although I'm not doing the biasing using my pulse demonstration module, but the DUT is still pulse demonstration module, right? So right now the biasing or the RF biasing is basically happening, or the RF pulsing is basically happening inside the vector star, which is actually connected to the pulse modulator test set. In the last video, actually the reference side, which is the A1 side, always had a CW as the reference signal, right, stored in it, and that's why there was no problem. But now, since we are doing the RF pulsing using our pulse modulator test set, even the A1 receiver is storing a reference signal which is pulsed in nature, right? So, and that's why we have the connection like this that you are seeing on your screen right now. So going forward, now that we have characterized, or we have configured our PG1, and the measurement is also configured, let's see. And right now I'm not decoupling the receiver, all the receivers are still covered. Let's see how our S21 measurement looks like. So when I press the done, this is not what I expect, because if you see on the left hand side of the pulse, this actually doesn't look right. It's not a perfect S21 trace. There is something wrong going on, and a person who deals in with pulse measurements will quickly see and tell you that there's something wrong going there in the pulse. All right, and now here is the deal, or here is the point where our software makes things very, very easy. Now let's do a simple comparison. I mean, I'm not making my receivers decouple right now, but I can make out that where the problem is happening. Let's do one thing. Let's add in or maybe let's just save this trace first, because this is what we are getting without decoupling the receiver, and this doesn't look right. So let me store this into the memory so that we can do a comparison when we are finished with our proper setups and all, right? So let me go to actually no need to go to the pulse view configuration. We just go here, and I do a log magnitude. Yes, I want that, but instead I want to see how is my A1 reference signal looking like. So what I can do here is I will do an A1 over 1, and I should be able to see what my okay, and I should switch off the averaging as well, because that fastens my process, right? So you can see here, and let me do a scaling as well. I do maybe a 5 dB scaling. Okay, and I put my frequency to 10 gigahertz. That's fine. So now what basically I'm seeing, oh, why is it B1? No, I have to do an A1 over 1 first. So A1 over 1 will actually show me what is the reference signal which is being stored now at the A1 reference or test receiver, because now this is a pulse signal. Why? Because the pulsing is happening internally, because our pulse modulator test set is providing the reference signal. So then I actually add in one more trace, say trace number 2, and I click on trace number 2. I also want that to be log magnitude only, but this time I want to see what is happening on my test or the receiver side, or the B2 receiver, which is getting the base, like the output from the DUT, right? So I go there and I press a B2 over 1. Let's see how the trace looks like. And if I do a scaling again, there you see, there is the problem. Now the reference or signal which is being stored at the test receiver is the one in yellow. Okay, and the signal after passing through the DUT, as I told you, my DUT has a big transmission line inside, and that's why it is adding a delay, right? So here in trace 2, which is green, I can see that the rise time of both these signals is not overlapping, and that's why my S21 measurement is not looking very good. So what's the best way of doing it? Now I can put in some markers on the yellow trace and then on the green trace, and I've done that exercise only, and I found out that the difference is basically 10 nanoseconds. And actually now, you know, using this live trace, I can go back to my pulse view setup. I click here and see what happens at the back. Now what I do is I make my receivers independent, and what I do is no need to make them independent. Let's see what happens if I keep it here as coupled. Now that I know that there is a delay of 10 nanoseconds, I just put in a delay here of 10 nanoseconds, and let's see what happens here. Now they are still coupled, but now I'm forcing my B2 receiver to actually see what's happening. Now look what happened. Because I did not decouple the receiver, even the A1 reference signal was disturbed. Okay, so and it moved by the same extent. So I go back here, I go back to my same settings of 0 nanoseconds, and I'm just doing this to let you know how you can actually make the measurement. So it comes back to the normal state wherein we still have that delta difference. Now again I go back here, I decouple, and now I put a delay of 10 nanoseconds on the receive side so that both the signals can be synced together. I do a done here, and let's see what happens. Now when I do put in a 10 nanoseconds of display, now you can see that they're almost overlapping, and you can actually play with it, but the whole concept of making these videos is the fact that how easily you can configure the entire dot. Now let me again add in one more trace to this thing, and this is S21, but I only want log mag. Okay, and I do a scaling for that as well. And okay, so now you can see that I have a trace 3, which now looks to be pretty good as far as the S21 is concerned. So I can actually play with the traces and the trace management. I don't want to see trace 1, I don't want to see trace 2, I just want to see trace 3. And now this actually looks like a proper S21 measurement that I'm making. So I can actually save this to the memory, and I just store data. Now let's see what happens if I go back in the pulse view configuration, and if I couple them and I do a 0. I just want to show you what are the wrong measurements that you will get. Alright, so this is a wrong measurement, right? And if I go on to display and I do a data and memory, this is the problem. So this is how you can actually configure your receivers to be independent, and it actually is very helpful. So thank you for tuning in, and we will be following that up with more measurements. Thank you so much.